Hey guys, Mr. B here again, bringing another awesome math video. This one I'm going to continue with my calculus series and bring you a few more trigonometric proofs or limits, and that's one of those tricky things. So when I last left you, I do believe we worked on an example here. I'm just searching for the paper, wherefore art thou paper, where we were using this guy right here. Anytime we're doing trig proofs like this, we essentially have to keep a couple of very important ones in mind. And this is the one that I'm going to keep in mind today. The limit as x goes to 0, sine kx over x is equal to k. So whatever number I have inside my sine function, so 5x, 10x, whatever it might be, in this case 4x and 6x, if I can get that thing over x, I know what the limit's going to be, that guy in the inside. And again, if you're looking for proof of this, that's not what I'm doing. I'm just basically applying it, which is what you guys will be doing in your math classes. So what you have to ask yourself when you're doing these proofs is, how do I get what I have here to look like this? So sometimes it's very simple. So in this case, how I can get this guy to look like what I need is to divide the top and bottom by x. So let's have a look and see. So if I go sine 4x divided by x. So I can do the same thing to the top and bottom. That's the important thing to recognize. I can do the same thing to the top and bottom and not change this limit. So I just divided the top by x and the bottom by x. So again, if you look, now I have exactly this thing. So I'm just going to, if I'm on a calculus exam, I want to make sure I emphasize to the teacher that I absolutely know what I'm at. So I'm just going to now I'm going to apply the limit to the top, and I'm going to apply the limit to the bottom. Sine 6x over x. So essentially now what I have is the limit of this guy. We use this guy, so sine kx over x is k. So the sine 4x over x is 4, and then sine 6x over x is 6, and then this guy reduces down to 2 over 3. So that's my limit. So there it is, guys, making your limit look like this guy. It's just a magical thing when it works out so lovely. Let's do another example. So there are like a billion different types. I'm just trying to give you guys sort of an overview of the few different ways that we kind of have these things. Alright, so here we have the limit as x goes to 0, tan 7x over sine 10x. I feel like a light is blinking or something here. What is going on here? Anyway, so what I can do is I can go ahead and rewrite this tan as the limit as x goes to 0. So tan is the same as, so tan of theta is sine theta over cos theta. So I can rewrite this guy as sine 7x divided by cos 7x. And then it's all divided by sine 10x. Now I personally don't like how that looks. So what I can do is sort of treat this sine as sine of 10x over 1, and then go ahead and sort of flip and multiply this over. So what I get basically is the limit as x goes to 0 of sine 7x all over sine 10x times cos of 7x. So this flips over basically, so it flips over like this, so it basically just multiplies that cos on the bottom. What's happening here? Alright, so now what I can do is, again, I'm thinking about how can I make it sine kx over x. So I'm in a similar situation. I've got a sine on top and bottom, so I can divide the top and bottom by sine, or by x, sorry. So let's go ahead and try that. So sine 7x, divide that by x, and then I'll divide the bottom by x. Now because the two things are multiplied on the bottom, I get to choose what I get to divide. So I'm not going to divide the cos, I'm going to divide the sine x so I can make that limit. So now again I want to sort of distribute my limits through here just to show the teacher that I know what I'm doing. So I'm going to take the limit as sine 7x over x as x goes to 0. So that's the top part. And then I'm going to do each of these individually. So I'm going to have the limit as x goes to 0 of sine 10x over x times the limit as x goes to 0 of cos 7x. So now I can do each of these limits individually. So I've got everything done. Note that this is multiplied here. So this limit right here is 7. On the bottom, I have 10. And this guy right here, so one limit we need to remember is that the limit as x goes to 0 of cos of x is equal to 1. So it doesn't matter what number I put in here, because essentially all I'm evaluating is cos of 0 is equal to 1. So if I have cos of 7 times 0, that's still cos of 0, which is 1. So basically this limit right here equals 1. And again, that's just direct substitution, so I end up with 7 over 10. There it is. Simple as that. Well, I shouldn't say simple. It's pretty complicated, but you know, it's one of those, another one of those examples. Let's try another one. So here we go. So here's another one. So this one's a little bit different still. So we have 1 minus cos squared on top divided by x sine of x. So what I have here is one of my trigonometric identities. So it's a Pythagorean identity. So sine squared a plus cos squared a is equal to 1. So the rearrangement of this for this particular function will be sine squared a is equal to 1 minus cos squared a. So that a can be anything. Could be theta, could be x in our case. So the limit as x goes to 0. So I'm going to replace this 1 minus cos squared with this sine squared x. So I get sine squared x all divided by x sine x. So now I'm in the situation where I can go ahead now and cancel a sign here, cancel a sign right there. So I'm left with the limit as x goes to 0 of sine x over x, and that of course is 1. So that's another situation, guys, where you might have to use one of your identities. So this one's a common one with this stuff. You know, it's a Pythagorean identity, so it's fairly well known. So I think your calculus teacher will probably be confident to give you a question like this and you'll be able to recognize that. Anytime you see a cos squared and a minus 1, you got to be thinking this guy. So keep that in the back of your head. All right, let's try one more of these guys, and I'll let you off the hook. All right, so we're in a situation now. We got a cos, we got a tan. So let's see if we can't change this tan to sine over cos again. So let's see what happens. So the limit. So really we're using one of our identities here again. So I'll rewrite it just to show you it. So sine theta over cos theta. Don't ask me why I use theta and a's instead of x. It's just habits. Don't ask where they come from. So then I have cos x, and that's sine x over cos x all divided by 7x. So then these coses can cancel just like that, and then I'm left with the limit as x goes to 0 of sine x over 7x. So I can sort of break this 7 and the x up into the limit as, because I want to make sine kx over x, in this case sine x over x. So 1 over 7 times sine x over x. So that limit, that 1 over 7 can come outside the limit. And then I have this guy, which is 1. So this guy right here is 1. So that we left with just 1 over 7. So there it is, guys. So like I said many times before, you've probably heard me repeat this, that knowing this guy is just absolutely invaluable. So sine kx over x is equal to k. So whatever number you have in here, sine of that divided by k is divided by x is equal to k. So it's such an important limit. I really hope it helps you. Thank you guys so much for watching. See you guys in class.